All right, welcome, ladies and gentlemen, to another live stream. Here we go. Let's see what we got here. All right, well, welcome. So, we're going into another exam or another live stream that I'm going to do for you guys on your semester exam. Hopefully, if you guys have them coming up this week or next week, then this live stream can be beneficial to you. Unfortunately, I'm not going to be taking any questions from the live chat, ladies and gentlemen, just because I get. Why is this going through there? Please. Going through. Okay. Yeah, just because I'm going to be getting as far as I want to be able to get to some of the math questions. So these are all math questions that have been pre-submitted to myself. So obviously a lot of times I like to interact with the chat. That's going to be all done on the kind of Sunday night stream, but I'm so happy for you guys to kind of join on. And hopefully, again, I'm going to tackle a whole bunch of questions. I'm not really I got like a whole different kind of a mix here of everything, but then we'll kind of get into that. And actually, I got quite a bit to go through. Am I muted? No, I shouldn't be muted. Can you guys not hear me? Should be all good. All right. So yeah, we'll be getting it. Dari, this is just an open live stream. So it does not occur with any class or anything like that. These are all questions that have been pre-submitted to me. So if you're wondering, hey, how do you submit questions? Maybe this is your first live stream with myself. Well, inside the chat, you guys can see there is a pinned message. And hey, Christy, good to have you. Ah, there it is. Oh, there's Christy. Well, yes, I'm not muted, so thank you. Hey, Christy. So anyways, if you guys have questions, inside the chat, you'll see a pinned message. Also on the replay, you'll see in the description, there is a Google form, or there is a website that takes you to a Google form, brianmclogan.com/Q&A. You guys can just go there and submit your questions, and each and every Sunday night, I'll go and answer them. But I wanted to add these extra streams because I got a lot of questions, that I know students, as they are preparing for their exam, needed help on. So that's what I'm going to be doing, for you guys. And then in addition to that, also just wanted to remind any of you, I do apologize. I meant to kind of put this out ahead of time, but for those of you that are taking pre-calculus and would like one of my reviews, this is not free. This is actually a paid review. So I do a lot of free things. This is not one of them. This is, it has actually my semester exam, my final exam, and my free response review, my multiple choice review, and I think a practiced exam for each of them. So it's a lot of content. And then also, I am doing a additional private stream within that course this Saturday. So if anybody else has an exam, like I said, I know I probably missed some people that probably could have helped, and I do apologize for that. But for any of you guys that are taking the pre-calculus and you have an exam coming up and you'd like, hey, maybe this might be something beneficial to you, well, then you can go ahead and take a look at the link up there and go ahead and check it out. So otherwise, let's see, is this scrolling in? There we go. Perfect. All right. Well, it's good to have. Imagine helping me pass Algebra 2. You're good. Oh, well, thank you so much for that. And hello, you're on. Good. I can see that. Definitely is. Afsana, thank you. Fighting back cough. Hopefully you do better, Christy. All right, guys. So I am going to actually turn down the chat because I'm just going to get right into the math. And I know a lot of people are going to jump on. They're going to want to, throw in questions and everything like that. And I just want to relay again, guys, I'm just going to focus on getting this. Why is that not going through? Okay. Focus on getting these questions because my kids are coming home in 30 minutes. So I got to get to some math done. So, but I am going to keep it open, at least for the members only chat for you guys. So if you are a member or whatever else and you want to support me on that way, then you can definitely still stay inside the chat, but we're going to go ahead and move it to that way. So thank you so much, guys. I will, next time we'll look into something where you guys can do it. But again, if you do have questions next time, please, all my live streams, I can only answer so many questions, right? And I can only stay inside the chat. So my best advice for you guys is either pre-submit your questions at brianmclogan.com/Q&A, which again, that link is in the chat. It's a pinned message, or go to my Discord server. There is tutors that are there in the Discord server. And then there's other students that are just like you that are taking Calc 1, Calc 2, Calc 3, all the other different math classes that can help you out. Also, I always recommend that for you to help other people out. Like if you're in, pre-calculus and you're getting help from a calculus student, help somebody in algebra 2, or whatever may be the case. We can't answer every question. We can't help everybody, but whatever we can do is always greatly appreciated. I think we all know the feeling of being stuck, being frustrated, being stressed out, and then having somebody come in and helping them with the math. So I think that's really, really important. So, all right, guys, I am going to just get into some straight up math now, and we'll go from there. Boom. All right. So there are a couple questions that are actually left over as well from last week. So I'll try to do my best for that. Doing my calculator. Okay, cool. And I can't over talk everything. That's what I did last week. Did I do this one? No, I didn't. Okay, hold on. Do I have room? All right, let's put this one up here. Okay. So this question says, write the equation in its equivalent form. So for exponential form. So there's a couple different ways you can remember this. I always like to keep the base always going to be the same. And then it's going to, whatever it's equal to, that's going to be the new power and equals 8. Okay. Again, you could think of this like this. 3 squared equals 9. So that's going to be log base 3 of 9 equals 2. I would just have that memorized. And then whatever I do is I always just kind of relate it. So if I ever forget things, I always just kind of remember this logarithm. Sorry, now let's evaluate this expression. So I have log base 8. Now in this case, whenever we have radicals with logarithms, usually it's helpful to rewrite these as, usually we can go ahead and rewrite these as rational powers. Now, using my rules of logarithms, I can bring that in front. So I have a log base 8 of 8, which any logarithm, 8 raised to what power equals 8, right? 3 raised to what power 9, that's 2. So 8 raised to what power is 8? Well, that's just going to equal 1, which equals 1/2. All right, so now working together, Sam just said 2 hours of paint in one room. So this is going to be how long it's, so we have a room. So we're gonna need to create a proportion. So what they're gonna paint and then how long that's going to take them. Okay, so we know they can create a room in an hour. So let's go and see. So we have, when Sam is working alone, he can paint a room in 4 hours. So we can say 1 room in 4 hours, that's Sam. And then we could say plus, actually, let's just write it down here a second. When Jenna works alone, she can paint a room in 6 hours. So Jenna, 1 room in 6 hours. And then to determine how long it would take Francisco to paint 1 room on his own. So we don't know, we want him to paint 1. So that's gonna be Francisco. Okay, 1 room, and we don't know how many hours, but we know that when all 3 of them, right, they're going to all paint, they can all paint a room in what? They can paint 1 room in 2 hours. So all 3 of them can all paint a room in 2 hours. So now I basically just say all of these added up individually, we want them to equal 1/2. So now we just need to multiply. So we can see that I have 1/4 plus 1/6 plus 1/x equals 1/2. Let's multiply by the LCD, which in this case is going to be a 12x. So I'll multiply everything by 12x, and that's going to give me a 3x plus 2x plus 12 equals a 6x. 5x plus 12 equals 6x. Subtract 5x, 12 equals x. So he can paint in 12 hours. Paint a room. And that is Francisco. So I'll just draw a line because I'm time. Time is of the essence. This one was kind of a confusing one. It says determine the quadratic f of x equals ax squared plus bx plus c if the graph passes through a point. All right, so we have an xy point, right? A lot of times when we give us a point, I just like to write xy. It has a horizontal tangent. So obviously, the horizontal tangent, I was like, oh yeah, horizontal tangent, so we're going to have a horizontal line. But it's important, if you know a quadratic, what you know about this quadratic then is the horizontal tangent is going to be at the vertex, right? That's when the line only crosses 1 time, right? And it's going to be horizontal. So it's going to be at the vertex. Now, again, we don't know if this is a max or a min, but we do now know that this is going to be h comma k. So what was confusing about this was they gave us standard form. All right, so that's fine. That's what we're going to, we need to put it into standard form. But when we have the vertex and we have a point, we're going to want to use vertex form. So we say A, actually, so I'm going to, I'll replace it. So I would say y equals A times x minus h, quantity squared plus k. Okay, so now we're just going to replace our terms. So I have a 19 equals A times x because we don't know what a is, which is a 2 minus an h, which is a -1. Quantity squared, and then what? Plus 8, so plus a -8. All right, so let's go ahead and simplify this. 2 minus a -3, that's going to be 3. That's going to be 9. So 19 equals a times 9 minus 8. Okay, so plus 8 plus 8. Let's see, we get a 27 equals 9a. Divide by 9, divide by 9. A is equal to 3. Okay, so now we know what a is. But again, we're not done yet, are we? Because they still want it in, wait, determine quadratic. Actually, it doesn't say. No, determine a quadratic fx. Yeah, it does. Okay. So therefore, now we know a, and now we just need to expand this out. So I can say f of x equals 3. Let's see, x squared. We don't know what b is, and we don't know what c. What am I doing? Let's go back to write the equation up in here. You want to write it in the vertex form. Sorry. X, so this minus a -1 is just going to turn into a +1. Quantity squared, and we can write -8. This is what we need to expand. So we can do x plus 1 quantity squared. It's going to be an x squared plus 2x plus 1 minus 8. Make sure you apply distributive property here. 3x squared plus 6x plus 3 minus 8. And then we'll simplify that. 3x squared plus 6x minus 5. There you go. The surface area of a cylinder. So I think it's really important when you're dealing with surface area of any three-dimensional pictures is to always draw a net. Okay, and a net is going to be a two-dimensional figure that we can do to rewrite a three-dimensional figure, if I remember that definition correctly. So the best thing I remember for a cylinder is just going to be the best thing I'm going to remember for a cylinder. And hey, Eddie and Chrissy, good to have you guys. And Aubrey, thank you so much. Good game. I forgot what I was talking about. So the soup can, and again, when we're trying to find the surface area, what we're basically looking for is like if you want to think about this, like this net is going to be the materials that would make like the tin that would make your soup can or the aluminum. So in this case, if we were to like peel this away, what we'd have two circles. It'll look like this, right? So we'd have a top, a bottom, and then we'd have the sides, right? So top, bottom, and sides. Now, you notice that this length goes all the way around a circle, right? So that's the diameter, okay? So in this case, this length here is going to be the diameter of whatever the circle is. And so remember, the diameter is going to be 2 pi r. Okay, now the top is we need to find the area of that. That's going to be pi r squared, right? So that one is going to be a pi r squared. Actually, that's going to be the area. Okay, and then this one is actually going to be 2 pi r, and then this is going to be the height, right? So the area of the rectangle is going to be 2 pi r times the height. So we're going to have two areas of the circles, and then you're just going to add them to the area of your rectangle. All right, this was a long one. I usually don't do this. A lot to read and blah, 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 but it really doesn't matter. It's just all it is a circle with these coordinate points. And so what they're basically, I think the teacher is trying to help you learn to graph this without actually showing you the unit circle or the initial period, which is fine. So identify the coordinates, again, if you have a diameter of 100, then I'm assuming, right, then everything is going to be 50, how this is like drawn, figured out. So therefore every point is 50. So we could say, this one is going to be 0, 50. I'm assuming this would be a negative 50. And then 0, 50. Negative 50, sorry. Okay, and then the rotation is basically what we're doing is we're looking for the height at these different points. So at 90, the height is going to be 50. At 180, it's back to 0. At 270, it's negative 50. At 360, it's back to 0. And then you can see this keeps on repeating itself. So what the teacher is trying to help you get to is showing you, let's see, what graph. So plot the points. Relative. So I think, yeah, we're looking at the sine graph. So the graph is going to look, something like that as you keep on going through. Okay. And then obviously you can do your scales, 90, 180, 270, 360, and go on from there. Or it is definitely not linear or quadratic. It is neither. So, well, scissionoid. State the number of complex. So this is going to be Descartes' rule of sines you're going to want to use. Okay, I have a ton of videos on these that can definitely go over this more in depth if I kind of go too fast. But so say the number of positive and negative roots and the possible rational roots. Real rational. Negative roots. Okay. So forget about the 0. It doesn't really matter. For in this case, we're just going to call this fx. X cubed plus a 3x squared minus 14x minus 20. Oh, then it says then find all the roots. I don't want to do that. Well, I don't have time, but I'll show you what some things to do. Some ways you can do this. But anyways, let's go ahead and find the rational. So the number of positive is just going to be the number of sign changes minus an even number. So the number of positive real rational roots, is going to be 1. Okay. The number of negative, all we're simply going to do to find the negative, you're going to need to figure out the number of sign changes for f of negative x. So what we're going to do is plug in negative x cubed plus a 3 times negative x squared minus 14 times negative x minus 20. That show up? I guess I'll see it. Okay, cool. Huh. Oh, perfect. So let's go and see what we get here. So this would be a negative x cubed. That's going to be positive x 3 x squared. And this would be positive 14x minus 20. Okay, so we have 2. Okay, so we have 2. So the number of negative real rational roots is going to be 2 or 0, because you always got to subtract an even number. So, and then we could also have some complex roots as well, but that's going to be the number of positive or negative. So that's positive, that's negative. And then it says find the real roots. Now, this one's not going to be factorable. So not going to be as fun in that regard. There are some techniques you can go ahead and use and try using like grouping to be able to do that. But in my opinion, it's looking more difficult. So what I would do is try to find one root and then use synthetic division. So what you could do is use that by graphing. You could use the remainder theorem and just plug in some numbers and kind of see what works, what doesn't work from there. And let me just kind of do quickly off my head. I wouldn't want to use 1, maybe negative 1 would work. Let's just try f of negative 1. Let's see if this works. So if I did negative 1 cubed plus a 3 times negative 1, you're going to want to do negative, not positive numbers. That'd just be too big. So then be minus 14 times negative 1 minus 20. All right, so that becomes a what? Positive 1 minus 3 plus 14 minus 20. Nope, not going to be there. Okay, but maybe 2 might work. So anyway, you could go in the graph, but what you're going to want to do is find the 0. And so whatever the 0 is going to be, so find one of the zeros, and then I would just use synthetic division. So 1, 3, negative 14, negative 20. And again, how do you find the 0? Graph it, or use the remainder theorem by plugging numbers in like I did. And you just have to do a guess and check, really, from there. And you, did it say the real rational zeros? Yeah, the possible rational roots. Oh, God. Okay, so the rational roots is going to be plus or minus p over q. Okay, and so that's going to be p over q, which is your coefficient. So basically, you're just going to do all of the, doesn't matter if it's negative, you're just going to do plus or minus all of the factors. So it'd be 20, 10, 5, 4, 2, and 1. Okay, and thankfully, that's going to be all over our q, which is just 1. Okay, so I did positive 1, or I did negative 1. I would try maybe 2, 4 if you're going that way. But that's a long problem. We don't have time for that, at least now. This one says graph the log functions, graph the following on separate axes. Be sure to label the asymptote, state the domain for each. All right. So we know that if I had log base b of x, that graph's going to look something like this. Okay. So it really doesn't matter the base. I mean, that's going to be a stretch and compression. It doesn't really, the only thing we really need to pay attention to is our horizontal transformations. I mean, obviously we'll have vertical transformations as well, or we could, not in this example. So in this example, if I have log, I believe of 1/3, and then what you're going to want to do is factor out the 2, and that's going to be an x plus 4. Okay, so I'm just going to do a rough sketch, but the important thing I want you to understand is this graph is being shifted 4 units to the left. 1, 2, 3, 4. All right. And it had an x-intercept at 1, but now that x-intercept is going to be at -3. Now, the 1/3 of 2, those are going to impact the graph. But typically in my class, if we're not using like graphing calculators or we're not being exact, then I would just, as long as they can identify the transformations, I'm happy with it. But you could say that that is going to be a horizontal compression of the factor of 2, and this 1/3 is also going to impact it as well. Can you give a brief rundown of how to solve trig equations? Yes. So trig equations is basically solving like regular equations, just like, any kind of polynomial, quadratic, or linear. But then we need to go ahead and solve. And typically for that, we're going to either use a calculator or the unit circle. So typically in this, again, we have it set equal to 0. We're going to want to use, I can factor out a sine of x. And that gives me a 1 plus a 2 cosine of x equals 0, right? So we can say sine of x equals 0. And 1 plus 2 cosine of x equals 0. Okay, so, and then this is going to be -1, so cosine of x equals -1/2. Now, it doesn't say what the restriction is. In my last live stream yesterday, there was a couple questions I talked about that. So let's just do between 0 and 2 pi, which is basically on the unit circle. So we say, when is sine of x equal to 0? Well, it's going to be here and here. When is cosine equal to -1/2? That's going to be up here and here. Remember, cosine represents the x-coordinate on the unit circle. Sine represents the y-coordinate on the unit circle. So sine is going to be 0 at 0 and pi, and cosine is -1/2 at these two angles, right? Which is going to be a 2 pi over 3 and a 4 pi over 3. Okay. If you were going to do all solutions, I guess I might as well just do it. We could say x equals pi n would represent these two solutions. And then we could say x equals a 2 pi over 3 plus 2 pi n. And x equals a 4 pi over 3 plus 2 pi n. That's another way to write it. Sketch the graph of the piecewise function, then write the domain in notation. So again, piecewise functions, you're just graphing them separately and then applying the restrictions. So let's graph x plus 1. So that has a y-intercept of 1, and then up 1 over 1, right? That's the slope. Right, so y equals x plus 1, okay, right, so 1 over 1, so up 1 over 1, so, and then, so that graph looks like that. But again, this graph is only true for x values that are less than -2. So it's going to be from there, up 1, there, but it's only going to be true from here down to there. So the rest of this graph, we are going to eliminate. We're just going to go from where it's at -2, right? This is only true for x values that are less than -2. Now, notice I used a closed dot. It's not a closed dot. Oh, come on. That's so annoying. It's not a closed dot. It is an open circle, right? Because -2 is not included. Then we have -2x minus 3, which is greater than -2. So again, we're going to go down to -3. So 1, 2, 3. And then we're going to follow the slope, which again could be down, or we can go -2 up 1 and -2 up 1. Okay, and that's going to be all values that are greater than -2. So that's going to be a closed circle. And again, we can have from there. Now, again, notice this is a function, right? Because this is not included, that is included. But again, it does pass the vertical line test. A camel is tied to the outside of the corner of a barn. What is the maximum area the camel can graze outside if the red rope has a length of 20 meters. Okay, so I did check to this. So this is 6, that's 5, so that's going to be 21, right? And a couple different ways you can do that. So you could do, what I would just do is find the area of the circle and then subtract this figure, right? So if that's 6, then that's going to be a 36, right? So this is 21 times 15, so this would be, sorry, that's 11. So that's 11, and then this is 21, right? So then we have a nice circle, and it says 20 meters. So what you're going to do is find the area of the circle and subtract the area of the rectangle. Okay, so the area of the circle is going to equal, let's go and figure out what that is. So the area of a circle is going to be a pi times my radius, 20 squared, minus the area of my rectangle, which is going to be a 11, actually use brackets, 11 times 21 minus a 36. So let's put those in parentheses. And there you go. Then you can figure it out from there, hopefully. 21 shows 3 identical triangles inside a triangle. So the radius of each circle is 24. Okay, so immediately I find the area of the rectangle. So if these are all 24, right? Then we could say that's 24, that's 24, that's 24. Okay, so 24, that's 48. So this is going to be a 96. Now again, it doesn't work that way. We know that here though that's going to be 48. And then this would be 48. So if we cut that in half, right, we'd have an equilateral triangle. So if we cut that in, which an equilateral triangle, remember, has 30, 30, or 60, 60, 60. So now this is actually a special right triangle here. So let's see what we get here. So if that is going to be my 60-degree angle, this is 30-degree angle, this is 24, this is 48. Let's see if I can remember my special right triangles. Special right triangles. The short leg, I should remember this. Short leg divided by is 2, right? And then this is going to be 24 times the square root of 3. There you go. So to go from short leg to, there you go, 24 times square root of 3. To go from short leg to long leg, you just multiply by the square root of 3. Okay, cool. So then that is going to be, that's that, and then that's 24, and that's 24. Right? Yeah. Okay. So then the area of this rectangle, okay, so the area of the rectangle is going to equal a 96, right, width times, this is going to be a 24 plus 24, which is going to be a 48 plus a 24 square root of 3. And then hopefully you can use a calculator to go ahead and figure that out. Yes, I mean, so if you have a circle, the domain, what am I doing there? Let's actually just do it on there. Let's, so the domain of the range of the circle, the domain is basically the number of x values, right? That's going to be your input. And actually, you know what? Let's redo it better. Let's see if I can do it better. A good circle. There you go. So your domain is going to be the set of all x values, right? So if you look at this, and again, that's going to be like your input values. Stop. So we can see here we have 1, 2, what? 1, 2, 3, 4, 5. Okay, so my domain in this case is going to be 1. I'm sorry, not going to use set notation. Interval notation. It's all the values from 1 to 5. Whereas my range is going to be set of my output values, right? Which is going to be from 1 to 1, 2, 3, 4. How did I get this wrong? That should be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, so didn't really mean to do that. But the range in this case is going to be from 1 to 5, which is a set of all y values. There you go. Evaluate the difference quotient in here. You know what? I'm going to change this back in. I'm going to have you guys have a little fun now. So you guys have joined on. I only got like 10 more minutes. So let's go ahead and add in the chat. Boom. All right. So the next one is evaluate, but I'm not going to be taking any more questions. Sorry. I got to get through this. Evaluate the difference quotient for in this case. So this is going to be a f of x, right? So x plus h. So then you're going to do so what you're going to do is basically replace your function with x, or your x with x plus h. So you're going to have a 5 times a x plus h quantity squared plus a 2 times x plus h. And that's going to be minus a 5x squared plus 2x. And that's going to be all over an h. All right, so now let's just go ahead and simplify this. So we have a 5 times a x squared plus a 2xh plus h squared plus a 2x plus 2h minus 5x squared plus 2x. And then we can go ahead and do a little distributive property there. And did I do it? Okay, I just got to do it here. So I have 5x squared plus a 10xh plus a 5h squared plus 2x plus 2h minus 5x squared plus 2x. Oops, I am so sorry. I'm getting lazy. That's all over h. Right? Don't forget that. Where'd the minus 2 go? Why'd I have a minus 2? I don't know what I did there. But I guess we'll eliminate the minus 2. Not sure where that came from. All right, so this is all over h. And again, let's see what now gets simplified out. So we have 5xh, 2, that goes out. And 5x squared, oh, that was the squared right there. Okay, 5x squared goes out. The 2x, did I forget to distract? Come on, you got to be careful. You got to distribute that. So that should have been a negative 2x. So annoying. No. Undo. Okay. Be very careful. Oh, okay. Fine. That needs to be a negative. So annoying. Okay. So that becomes a positive 2x, and that's a negative 2x. And then now I have a 10xh plus a 5h squared plus a 2h. Because what's the derivative here? Derivative is a 10x squared plus 2. Okay. The 5h squared. 5h squared, what happened to my 5h squared? Where did that, and that's going to be, that's all divided by h. And so that gives me my 10x plus 2. But why do I have my 5h? What happened with that? X squared, 5x squared, x plus h. Uh-oh, my kids are home. Crap. Oh, no, that's the x plus h. X plus h, evaluate the difference quotient. Does anybody see my mistake? I don't remember it. It's been so long. That's why I don't go through this. 5x squared plus 2. I'll have to go back and look at this after I'm done. All right, the next one, simplify the following. Find your final answer should not include radicals. So the student wanted me to do B. Oh, I'm almost done anyways. Okay, cool. So in this case, we're going to do a 3x to the 4th. First thing I would do is whenever you have a negative, go ahead and rewrite that as the reciprocal. So what you're going to want to do here is just rewrite this as a 4x squared over a 3x to the 4th. So by rewriting this as reciprocal, you can now rewrite that as 2. Then we can use the power to product rule as well as the power to quotient rule. Basically, that means you can distribute this 2 to every single term. So I have a 4 squared times a x squared all over a 3 squared times a x to the 4th quite squared. So that's going to give me a 16x to the 4th all over a 9 x to the 8th. And then I can simplify this a little bit further. Can't really do anything with the 9 over 16, but I can simplify that. Remember, subtract your powers. So that'd be a 16 over 9 x to the 4th. Yeah, Veronica. So the next one is an observer in a hot air balloon some distance away from the aqueduct determines that the angle of depression at end is 54. So let's try to draw this. So we have a point. So we have 54 degrees and 71 degrees. Okay, so we have let's do a horizontal here and horizontal here. So let's call this 54 degrees. And that one is going to be a 71 degrees. The horizontal distance between the balloon and the aqueduct is 270. So let's just call this the aqueduct right there. So we have the balloon. So the horizontal distance is 270 meters. Calculate the length of the aqueduct. So we want to basically, hold on, that's not right. The observer in the hot air balloon. Oh yeah, you want to, yeah, okay. Horizontal distance, yeah. Sorry. Okay. So basically, yeah, here it is the aqueduct, right? So we want to find this height. But why would the horizontal distance between the balloon and the aqueduct is 270. Calculate the length of the aqueduct. Oh, okay. All right. Never mind. Okay. I see it. they want to find this. Yeah, here is the aqueduct. Gotcha. So it's a horizontal distance. Okay, now I got it. All right, so basically what we need to do then is we need to, these are crappy problems. I hate these problems. Oh, come on. So basically what we need to do now is we need to set up a couple different triangles. All right, so I'm going to set up the triangles. I don't think I'm going to have time to do all of this. This is quite a bit. But so we have one triangle. Let's just draw triangles. So that's 270, right? So it doesn't say how tall it is, right? That's fine. 270, and then this is 54 degrees. Now, with this information, though, we can be able to what do I want to try to figure out? I'm trying to think. These problems can always be tricky, and sometimes we do different ones for different ones. So we're trying to look. Oh, that's so annoying. Stop that. Okay. So that's going to be our A, right? So we want to be able to figure out A. And that is going to be 54 and 71 degrees. The horizontal distance between the balloon and the aqueduct is 270. Calculate the length of the aqueduct. Calculate the length of the aqueduct to the aqueduct. To each end, right? And then the distance between the balloon, yeah. So I mean, it says the distance between the balloon and the aqueduct, but you don't know the length. So it's kind of confusing. It's hard to get the picture. The main thing you're going to want to do is be able to set up your different equations here, or your different triangles to be able to set this up. And now this one's going to be 71. And so what you could do there you go. So you can have that one, and then you can have another triangle, which that's not going to help me out. We want to be able to figure out this, right? So if that's 71 degrees, if that's 90, then you could say this is going to be 29 degrees, right? So I'm assuming if I'm understanding this question correctly, that's 270. And you could just be able to figure out. I don't think I have the question written out correctly or drawn correctly. But you could go ahead and use, if you have this to be in the height, then you can go ahead and find, let's just call this B, right? So therefore you could be able to draw a picture from there. That's why these questions can be difficult. H and B, find B, and then you subtract that from 270. But I don't think that is correct, because it says how to balloon distance aqueducts in terms of angle of depression to each end. So those are your two ends of your aqueduct. And the horizontal distance between the balloon and the aqueduct, I'd have to go in visually. I'm getting confused. I've already done too much math. All right, apologies. I'll have to look at the visual. This one, I messed up on this one. This was actually from last class period. So graph the reciprocal function. So again, basically you want to figure out what the function is, right? And we kind of did that. So y equals a, it does have a regular thing. That's going to be a x plus 1 quantity squared, and then what, plus 3. Okay, now what you can do here, what I kind of got a little confused here is what I confused myself. What I would do is rewrite this in standard form. Okay, now you can rewrite this as the reciprocal. Okay, so the reciprocal is y equals 1 over x squared plus 2x plus 4. Now, it's important for you to see that this domain is never going to be, this value is never going to be 0. Okay, it's never going to equal 0. It's not factorable, you're not going to, it's not going to be set equal to 0 for any real rational zeros. So if you want to find the domain, in this case, that's going to be for all real numbers. As far as finding the range, you could go ahead and find the inverse would be a typical, we'll be able to find the domain of the inverse for in that example. Or what else do we do from that? You could find the intercept or look for the asymptotes. So in this case, the asymptotes is x to the 0. So whenever the denominator is greater than 0, then y is equal to 0 is a horizontal asymptote. So I'm going to assume, again, I would just double check looking at it because I'm not familiar with that graph. That the range, though, is going to be from negative infinity to 0, union 0 to infinity. And that should be the only horizontal asymptote, and it should be defined for everything else. All right, and then the last question that I had here was the trunk of a leaning tree makes an angle of 12 degrees with the vertical. So let's have a vertical. Then let's have a tree. Okay, and that tree has a degree of 12 degrees. Okay, so 12 degrees with the vertical, prevent the debris from trawling. And a 35-meter rope. Pegged to ground some distance away, because you're treating it, so it obviously doesn't want to go that way. If the tree, so again, that's 90 degrees, right? If the tree is 20 meters, if the tree is 20 meters from the base to its top, so that's going to be 20. All right, calculate the angle the rope makes. Calculate the angle the rope makes with the ground. Oh, okay. Well, I'm not really seeing, in this case, if that's 20, if the tree is 20 meters from its base to the top, oh, that's 20 meters to the base. Okay, wrong way. So then list length is 20. Okay. So what I would do in this case is we need to be able to figure out the height. That's what we have to figure. We have to be able to figure out this height. All right. So if that's 12 and this adds to 90, then I know that this has to be a 78 degrees. And remember, that's 20. Right? So we have a special right triangle. That's 78 degrees. That's going to be 90. And that's going to be 20. And we need to be able to figure out this height. That's opposite over, that's hypotenuse over opposite. So I'll say the sine of 78 degrees is equal to 20 over h, right? Opposite over hypotenuse. What am I doing? Jeez. Opposite over hypotenuse. Okay, so the height equals a 20 times the sine of 78 degrees. So let's do 20 times the sine of 78, and that's going to be 19.6. Okay, 90 for 9.6, what is that, meters? Okay. And then, so now we know that. Well, then all we need to do now is figure out this angle. So now we have this big triangle, right? We have 19.56, and we have a 35 meters. And if we're trying to find this, then again, it's a right triangle. So therefore we can use, if we want to find theta, that's going to be hypotenuse over opposite. So again, we'll use sine. So I'll say sine of theta is equal to, opposite over hypotenuse over opposite over hypotenuse. So 19.56 divided by 35. Now I'm going to actually use the stored answer in my calculator, and I'll use sine inverse of 19.56 over 35. So I'll do the sine inverse of that answer divided by 35. Okay, and that's a 33.98. Theta equals 33.98. Okay. That's awesome. All right, I just want to go ahead and look at this real quick. I want to see if I have back in my video that I have from this. Let me see if they... I thought I had something similar to that. I'm not seeing that go. So anyways, guys, just to let you know, hopefully this will end it, at least for the live stream that I do have for you guys, or at least as far as on that regard. The one thing I just want to let you guys know is, again, the link is for those of you guys that are in pre-calculus that would like to take a look at my review that I have for this case. Then feel free to go ahead and check that out. And then otherwise, for those of you that are taking your exam, hopefully this was helpful. Again, we'll be taking questions on Discord. For you guys, I'll be taking questions along on Discord for you guys, and I'm sorry, I'll take it. Taking questions again on my live stream on Sunday night, or you can also put your questions in on Discord. So 7154. If that's 71, then that's 71. Okay. Oh, 270. Oh, so that's the hypotenuse. That's at least how they... Because an observer has some distance away, aqueduct determines the thing. Okay, so it says some distance away. The horizontal distance between the balloon and the aqueduct is 50. Okay, I think that problem is just a little too confusing with going from there, so I will just delete what I have from there. But all right, let me go ahead and get from you guys. Awesome. Yes, well, I'm not taking any more questions. And for you guys, if you have any other questions that you guys want to go ahead and submit, please go ahead and check a look at the Discord. Again, it's in the chat for you guys, or you guys can go ahead and catch me next week on my live stream. Again, all you got to do to submit your questions, guys, is to go ahead and plot it into brianmclogan.com/Q&A. That link is also saved on the chat. All right, guys, I have to go and get some dinner. Thank you so much for joining in, and I wish you, if you guys do have an exam this week, I wish you the very best of luck. All right, cheers.